Hi everyone, I'm here to present our simulation tool for time synchronization between TSN and 5G in the OMNeT environment. For that, make sure to have imported the ENET and Sim5G models as well as our project inside the OMNeT workspace. To run our simulations, we run the omnet.ini file inside the TSN 5G, which imported some default parameters defined in other ini file. Here we set which direction the time synchronization occurs inside 5G, by downlink, uplink, or passing between user equipments. We first chose the downlink case. In this case, the grandmaster is the node called switch 5GC, and in the beginning of the synchronization, all nodes calculate the period delay between the devices that will send synchronization messages. Here we can see how the message goes through the 5G system from the DSTT to the NSTT and later from the NSTT to the DSTT. Even after all period delays were calculated, the user equipment and the base station will continuously exchanging messages. So for the demonstration, we accelerate the simulation for the time the sync messages will be sent. Now we can see the synchronization messages starting to be sent. For the 5G, the time the synchronization message stays in 5G are calculated by the ingress in the NSCT and the egress at the DSTT. After the first synchronization, we see that the time difference between the nodes and the grandmaster in both TSN domains are decreased. And as the process repeats itself, we accelerate the synchronization until it ends at 200 seconds. Now we are present the uplink case, where the switch TSN is the grandmaster, but the whole process is pretty similar to the downlink case. Now, in the last case, we have time synchronization methods passing through one user equipment to another. For that, we simulate this case in another environment with one more TSN domain. But the grandmaster is still the switch TSN, and the PLC and switch 5GC don't participate of the time synchronization. Even though the time synchronization methods could be passed more directly between the user equipments, the 3GPP establishes that they pass through the NSCT to be forwarded to the correct device later. For visualization of our results, we can go through the VEC files created by the OMNeT and search, for example, for the time difference of the device clocks. After choosing the modules to analyze, we see that the graphic shows the time difference related to the simulation time and not the grandmaster clock. As by default, in our project, we set the grandmaster clock to have a constant drift, we can just apply a calculation for see the desired results. As it happens in all our cases, the time difference is much bigger at the beginning of the simulation compared to the rest, because the synchronization process always apply a oscillator compensation in our clocks. After applying a vertical zoom in our results, we can see that after the first time synchronization methods, the actual accuracy of our synchronization is of dozens of nanoseconds for the downlink case. The same happens for the uplink case, and it just changes a bit for the last case that reached few nanoseconds.